Okay, so you're back from breakfast.
Yep.
So first, what was your approach to this problem?
Well, I went systematically. I picked values for x, and then saw the largest value I could make with the remaining numbers, and then I kept on checking until I got it.
Okay, and your approach was basically...
Yeah, I think I did almost the same thing.
Yeah.
I just...
In fact, you guys did. You guys
yeah.
both independently did the same thing.
Cool.
What are some ways that would have made your approach the same, but maybe a little bit faster?
Well, for me, I think when I realized it was so low in the beginning, if I had jumped to the end and then checked that, or maybe if I had checked in the middle to see if I needed to go lower or higher.
Okay. What do you think?
Well, maybe we could have found some algebraic way to figure out it. So maybe it would be like 3x plus 2y plus 2z. Then that sum equals 47, and you could try it to see if you could find that sum.
Yeah, that might actually be very tricky, but I'm not sure. But I want to explain it a slightly different way to you guys.
Okay.
All right.
So here's a question for you. What's the longest this game could last?
Well,
You go until like the last possible roll where you can see the third number for the first time.
If you got a 1, then a 2, then a 3, then a 4, etc. So you got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And then the game would last 13 rolls. Because then on the 13th roll, you'd be forced to get something you already got 2 times it.
What do you think?
Yeah. Because, that would make sense because you'd already have all of them done twice, and then you could just roll.
1, 2, 3, 4, 5, 6. So this is something called the pigeonhole principle. You've got 6 buckets, which are the numbers, and then we're filling up the buckets.
Yeah.
And the most we can fill them up with is twice each.
And then you have to put this one into one of them.
And then on the 13th roll,
Yeah.
you get it. Okay, sorry, go ahead.
I think we have the pigeonhole principle in the math book that we got.
Yeah, it is actually. You're right. What would the sum be here, by the way, if you got to this situation on your 12th roll where everything was all spread out? What would the sum be?
Well, the sum would be. It would be.
Well, on the 12th roll.
Be 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. Then times 2. It's 42.
Okay. So if you spread them out as much as possible on the 12th roll, you get to 42.
And then if you rolled a 5, you would get to 47.
On the 13th roll.
Yeah.
But the problem said you rolled 12.
But you got to 47
On the 13th roll.
on the 13th roll.
So
that would mean you'd have to...
On the 12th roll.
Yeah.
The problem was you got to 47 on the 12th roll. But if you spread them out as much as you possibly can, the way you would get to 47 on the 13th roll was with a 5.
Yeah.
So that would mean you'd have to have 3 6s.
Why?
Because 3 5s wouldn't increase enough. Wouldn't increase the number enough.
Yeah, so if you're going to get there on the 12th roll, you're going to be missing one of those spread out numbers. And instead of going into one of the buckets, it's going to go into another bucket. But does it have to go into a small bucket or a big bucket to get to 47?
Well, like the number 4 bucket or the number 2 bucket?
What do you think? If you're getting to 47 in 12 rolls.
I think the numbers would have to be fairly large.
Yeah. Because if you wanted to get, and you can't use like 4 6s to get there.
Right, because the most you can use is 2 6s, right?
Yeah.
So that would point towards 6 again.
It points towards 6 again. So both of you started looking at 1 first as the potential one.
Yeah.
But that's a small number.
So I was thinking, you could look in the middle and then see where you needed to go.
See if you needed to go higher or lower. But if we kind of stop and think through the problem, thinking about the pigeonhole principle, it turns out we need kind of a big number to make this work. If we were doing it in 13 rolls, we needed a 5.
Yeah.
And so do you think you need a bigger number or a smaller number to do it in 12 rolls?
Probably a bigger number.
Probably a bigger number. So that suggests taking a look at 6.
Yeah.
So that's one alternate approach. Alright, good. Good job this morning, guys. It's interesting to hear you guys talk through this.